Hey guys, welcome back. So in this video, we are going to solve the Tower of Hanoi problem using recursion. Let's discuss the problem statement. What is Tower of Hanoi problem? Tower of Hanoi is a mathematical game or a puzzle. It consists of three rods as you can see on the screen and a number of discs of different sizes, which can slide onto any rod. So the puzzle starts with the discs in a neat stack in ascending order of size on one rod, the smallest one at the top, thus making a conical shape. So the objective of this puzzle is to move the entire stack on another rod. But while doing so, there are certain rules that must be followed. Only one disc can be moved at a time. Each move consists of taking the upper disc from one of the stacks and placing it on the top of another stack on an empty rod. No larger disc may be placed on the top of the smaller disc. So, for example, if we have four disks, then how will we identify that this problem can be solved using recursion? We will analyze if this problem can be solved by breaking it up into smaller identical problems until we get to some base case. Then we can solve this problem recursively. Alright, here we have four disks. We can reduce the program size by decreasing the n to get similar smaller problems. For example, if we have solved the Tower of Hanoi for 3 disks, that is for n equals to 3, then we can add up the implementation to solve the problem with 4 disks. So let's go through the steps to solve this problem. So first is knowing what the function should do. So we will be having a function Tower of Hanoi, and this function is not going to return anything. It will just print how we are moving the disks. So we will only be having print statements. We will not have any return type, or will have void as return type. And what the user is going to provide us, is going to provide us n, which is the number of disks we want to move from a rod to the two rod. So in this game we have three rods, one where the disks are placed currently, which is the from rod, and one where we have to place the disk, which is the two rod, and one more is the auxiliary rod to help the shifting. So these also must be taken as these all are variables. So we're taking them as input parameters. Now the second step is picking the subproblem and assuming that the function will work for that problem. So if our original problem is for 4 disks, then we can assume that this function will work for 3 disks. See this method. Here I'm taking aux at second position, where for original problem we are taking the 2 rod. Because to complete the original problem we need these 3 disks at this auxiliary rod, so that we can take them and can directly shift them to the original 2 rod. So for n equals to 3, the from rod is same as the from rod of n equals to 4, but the 2 rod for n equals to 3 is the aux rod of n equals to 4, because it is helper rod for n equals to 4 problem. Now the third step is adding up or using the result from the previous problem to construct the solution of the original problem. So now if 3 disks are already solved, how we can use this result for 4 disks? We can shift the fourth disk from the from rod to the to rod, and then move the 3 disks over it. So this is the solution to the Tower of Hanoi problem. First we shifted all the disks other than the nth disk from rod to the auxiliary rod. And then we moved the remaining, that is the nth disk, from rod to the to rod. And then finally we shifted all the disks present at auxiliary rod to the to rod. Now comes the fourth step, which is identifying the base condition. So if we only have one disk, that is if n is equal to 1, we can directly put it to the to rod, right? So we'll take it and we'll move it from rod directly to to rod. That's it. So if you can solve the problem for the current step correctly, considering all the variables, then rest everything would be solved by these recursive calls. Now let's try out the solution in IDE.